Okay. Regressions. Find the line, actually no, curve of best fit. The curve of best fit, not perfect fit. Although most of the questions, it is a perfect fit, but in real life, you would find the curve that would best model the situation, okay? You're modeling, which is gonna happen at lunch as well, right? Is there a modeling contest, right? Anyways, but you're modeling, you're trying to come up with a curve that models a scenario, okay? That's what we're gonna do. So this precedes you getting your equation. Right now we're getting our equation. Now we don't have an equation. You wanna know a secret? I bet you the province does the same thing. I will give you a bunch of points here, for example. I probably already made an equation. I came up with an equation, and I just went second trace 1 and go -7. What's the y value? What's the y value? Like I just come up with random points that are on that curve. I put them down, and then I need you to come up with the equation. Okay, so I kind of did it backwards. That's usually what happens. So those points are on the curve somewhere. Okay, so we're going to come up with the line of best fit. Okay, before you were given the equation, right? You were given the equation so far. You entered it to y1 and you went to town. Okay. Now in this lesson, you will determine the equation. Here it is one more time. Curve of best fit. I don't know. I feel like it's okay to do this more than once, right? It stands out a bit more at the very top. We will use, here's where it changes from last year. We will use linear regression, quadratic regression, and cubic regression. Okay, to determine the equation of best model. So we will have to resort to one of these three. Last year in grade 11, all we did is quadratic. Now we just mix it all up. It's all of them. Okay. To access any of the above regressions, press Stat Calc. Can you please do that to refresh your memory? You want to go press Stat, and then go to Calculate, and there they are. Right? There's linear regression 4, quadratic, quadrag, and then cubic reg. So we're going to park in those three right now. Please do not use 9. That one, some students think that that's linear. That's not, right? So you got to stick with linear there. That's the linear. This is natural log, which we're going to talk about later. Okay, so example, when you do this right, you should see the regression you're performing, a location for the x values, a location for the y values, and then where you're going to store the resulting equation. Okay, so that's always what I'm going to do in this class. They're separated by commas. Entries are separated by commas. You got to make sure you understand that. So I'm going to highlight the commas here. There are 2. They're not just there to tell you that it's separated. They actually need to be entered. And here are the steps. This is actually copy paste from grade 11. You turn on plot 1. We only have to do this for on regressions, right? Turn on plot 1. Only need to do this for regressions, like when you're actually going to perform a regression. We're going to press Stat Edit, enter our x values into L1, y values, right? X values L1, y values go into L2. Make sure you clear any previous data. We're going to do that. Third, press Zoom Stat. Look at the scatter plot. Okay. This is newer because we have to decide sometimes what does it look like. This is what I mean. Is it going to look like this, right? which is linear, is the scatter plot going to look, is it going to kind of simulate like a parabola, right? This is a quadratic, or is it going to, am I going to look at my scatter plot and is it going to sort of resemble a cubic? That's why you want to do this step right here. Although most of the time, the province has been known to just tell you, hey, find the cubic regression. It's like, oh, okay, then just do what they say, right? Don't argue with them. And then this one, I honestly don't need you to worry about this. I'm just going to show you how to make that happen, how to come up with your quadratic regression. This is what you want to see on your home screen. Or cubic reg, right? Like so, some students think it's always quad reg, no. Or lin reg, right? So you get the gist, right? You get the idea here. So let's enter this into our calculator. Whenever you're given a table of any kind, you type the first one into L1, the second into L2. So grab your calculators, press stat, and then just hit edit. Let's clear whatever is there. So you go to the very top, you press clear, not delete, and hit enter, and it gets rid of everything that's in there. So clear and enter, everything is gone. Let's enter these values into L1. So -4, not minus, right? It has to be the negative button. And then -5, 2, enter, 1, enter, -8, enter, and so forth. Make sure they match. I should make sure that I got this right. There we go. I kind of broke the rule. The first one was turn on stat plot 1, sorry. Turn on plot 1. It's probably a good idea to clear everything that you have in your Y's. Like just get rid of it. You don't want a line sketch there. So let's hit graph altogether. You see a little something happening here, okay? But I don't like that very much. This is where I use zoom stat for sure. Like when I want to see scatter plot, I use zoom stat, and there it is. So I'm going to go zoom stat. Make sure you turn on, I will put that in here, turn on plot 1. If you don't have plot 1 turned on, zoom stat isn't going to do a thing, okay? So now we look at those points like that. Doesn't that look like it has to be a parabola? Wouldn't you agree? It has to be. Like a linear just couldn't do it. A parabola can do a pretty good job at connecting those dots, okay? So looks like a parabola. Therefore, quad reg L1, L2, Y1. We're going to put that equation that we come up with into Y1. So here it is. You ready for this step? This is a throwback from last year. So we're going to go stat, calculate. We are going to pick quadratic regression, hit enter. Then you want to go second 1 to call L1, comma, second 2 to call L2. And here's the kicker, comma, anybody remember this step? Alpha, you press alpha, trace. And you pick which Y you want to put it into. I want Y1, so I'm going to select Y1. There it is. And now I'm going to hit enter to actually run the regression, to run the program. There it is. So I'm going to write this down. Y is equal to -0.44 x squared plus 0.11 x plus 2.56. There's my regression. Done. I can now hit graph. Because it's stored in Y1, if I hit graph right now, it's going to actually graph the parabola that fits that scenario. Okay? That's regressions, guys. That's what it is. Okay. I will not do the rest here. I will jump straight into word problems. I just needed to refresh your memory on how to do the regression. Okay. So we're going to go to 36. And if I need to add anything, I will do so later. Regressions involving a context. Okay. So basically word problems. You may be asked to create a scatter plot. The same rules apply. This is very, very important, okay? You may be asked to create a scatter plot of the data on paper. I'm talking here, not on your calculator. The same rules of graphing apply, okay? Nothing changes. You still have to label your axes, include units, appropriate scale, reasonable domain and range, important points clearly placed, and correct shape of the graph. So it may be that, right, we graph this would be the curve, but if they ask you to do the scatter plot, you would just literally just put down the dots. It hasn't happened in a while, but if they do, that's what they mean. Okay, so and you will know the points. They will give you a bunch of points to do this. You just have to make sure your scale is good and you label it. Okay. Sorry, I should say scatter. Okay, scatter plot. Let's jump into our first example here. A carpenter is repairing a wooden arm for a chair and takes careful measurements. If he can determine an equation, he can get a computer-controlled cutter, like a CNC, right, machine, to make a matching arm. The arm has a horizontal length of 45 centimeters. That's probably worth highlighting. Just, it might come in handy later, maybe not right at the beginning. But here's your data. Here's your data. As soon as you see a table, you should be thinking, regressions, regressions. So we're going to put this into L1 and this into L2, and they're never going to trick you. Whatever goes into L1 is your X variable. Whatever goes into L2 is your Y variable. Let's enter this information into our calculator, shall we? I'm going to go stat, edit, clear everything that's in there. Have you ever pressed delete? You know what happens when you press delete instead of clear? It gets rid of the entire column with everything in it. If that ever happens to you, because on the exam I cannot help you with that. I might. No, right? So what you want to do is set up editor, right? You go to stat, instead of going into edit, you go set up editor, and you just hit enter, enter. It will fix anything you've deleted. Okay, it will bring it back. Okay, stat, edit, let's enter this. 0, 5, 10, 20. It's like an Excel spreadsheet. That's what that is. Okay. Sometimes this will round the values. As you're entering it, it will round it for you. Don't worry about it. It actually will use the values you've entered. You're just seeing a display of a rounded answer. Because oh, sorry, I just 5, 1.36, 0.04, 1.705. Make sure you take your time and enter it properly. take a moment to check. This is such an easy, like, you can lose marks just like that by missing one, because if you miss even one value, you lose the mark for the equation. You might get everything else, but the mark for the equation you lose. Now let's do our scatter plot. How do you do your scatter plot? You can hit graph and try. So there's that equation in there. I want to get rid of it. I'm going to clear Y1. Plot 1 is turned on. So I'm going to go zoom 9. What does that look like? Cubic, right? Not linear for sure. Not quadratic, because a quadratic can only do this part, but it can't do this. So it's a cubic. So we know what regression would best fit the data. Justify your answer in words. The scatter plot indicates 2 turns. Right? This can only be done by a cubic function. So you just use your own words. Sometimes some students will actually say, hey, this is the scatter plot here, and just resemble it. Right? It has 2 turning points. It has to be cubic. Okay. So let's do that. So I go stat, calc, cubic reg. This is the standard way of showing your keystrokes there. Cubic reg. So stat, calc, cubic regression, hit enter. You got to go second 1, comma, second 2, comma, alpha trace. That calls Y1, alpha trace. Hit enter, and here you go. Just copy this down. Sometimes the province will ask you to state it in 3 decimal places. Just do what they ask you, but if not, it's 2 decimals. So negative, wait, is this what we're getting? Yeah? Okay. I don't want to do this whole thing and then I go off script most of the time. 0.6. 0.6 x squared, right? It's an x squared. Just follow the top here and just fill in A, B, C, D, right? Minus 1.00 x. And the last digit, that rounds to 5 if you round it to 2 decimals. So we just go like that. I was just going to warn you today, and I fell for it. Thank you very much. Thank you very much. I did this on purpose for that to happen, except for I missed it. Did anybody notice this? Okay. I messed up big time here. This is not correct. Let's make a note here. A is equal to negative 8.849 something times E negative 4. Okay, that's what it says for it. This is the equivalent of saying negative 8.849 times 10 to the negative 4. That's what that is saying. Okay, it's saying that part. So we shift the decimal 4 places over to the left. So watch what I'm going to do. I'm going to go 1, 2, 3, 4. That's where the decimal goes. And the values you've created, you just fill those in with zeros. Okay. So 4 places. Shift 4 places. Can you see that? Yeah, it's on there. Shift 4 places. Thank you very much. That would have been very bad. So that's negative. And so please don't put 0 down, right? Then you just have to go with as many decimals as are required until you get a non-zero value, okay? Phew. I will highlight that. I should be specific. Shift 4 places left. Okay. So I'm going to go watch. Watch out. Okay. I think I have students that pay attention. It's almost like you probably there's less likely to forget because this happened to me. I'm just hoping for it. Okay. There you go. What's the highest vertical displacement? Oh, wait, what, right? So we know that X represents the horizontal position, so, right, side to side, and vertical displacement is, right, like how far up and down is this thing going? So what's the highest vertical displacement, right? Highest Y value in a sense, because it's worded that way. So let's go ahead and find it. Graph it. There we go. Beautiful. You may have to adjust your window if you want to see the whole thing. So I'm going to adjust my X max just a little bit. I'm going to go 60. There we go. That's good. The highest, it could be here, right? It could be the max here, or it could be your y-intercept. We'll see. We'll find this one right here. Let's do it. Second trace max. I am to the left of it. Hit enter. I am to the right of it now. Hit enter one more time. So second trace max. And this is 3373, 5.05. The reason why I put down the whole coordinate is because you may need it later on for graphing purposes. So you might as well, while you're at it, just put down the entire thing. So what's our y-intercept? It's 5, right? This is a little higher. So max vertical is 5.05. We are in centimeters according to that table. I'll make a note. Note y-intercept is 5 centimeters, right? So this is a bit higher here. What is the zero of the curve? What does this represent in words? Anybody remember what the zero is? The zeros are the roots, and roots also mean x-intercepts. They all mean the same thing. Okay, zeros, same thing as roots. Let's go ahead and find them. y2 is equal to 0. Second trace 5. y2 is equal to 0. Hit graph. So there'll be 1 here and 1 there. So this one only has 2 x-intercepts. However, what if there would be another x-intercept on the negative here? Technically, we don't care about that one. Okay, we only care about these 2 here. Second trace 5. Enter, enter, enter. That's 11.620. One more time. I don't know if I showed you the trick. Instead of traveling along the blue, you can go arrow up or down, jump to the other line, and then just cut right through, and then still do the enter, enter, enter part. That's 44.99 technically. Zero. What does this represent in words? What do you, I'm trying to think what my reasoning was here. This is like if you're putting this piece of wood, like a big piece of wood, right on this table and it cuts it, to me, this would be the edge of the board. Would that make sense? Yeah. So within the context, these points are located towards the edge of the board being cut. You want to imagine like a piece of plywood maybe, right? And this machine is going to go and cut it, right? Like that. So the edge is, you're right against the edge of that piece of plywood. Keep going. I know it's a lot, but I over explain sometimes. I know I'm guilty of that. Next page, state the y-intercept. What does this tell us in this case? The y-intercept is 0D, right? So it's 0, 5. It gives the initial position of the cutter. Okay. So that's all I would say in this case. When there's a horizontal displacement of 0, the vertical displacement is 5. So it's just the initial position of the cutter before it starts to cut. And here's graphing the scenario. I will say this. If a table is provided, use those points. Use the points to graph. It's almost like basically you were given a table of values, correct? You were given a table of values. When the province does that, your safest bet is to use those points to make your sketch. So I'm gonna try to, I have my other copy here. I'm gonna have these points right next to me to help me out. So here we go. This is vertical displacement in centimeters. And here you have horizontal displacement in centimeters. And then you just come up with a good scale. It says that this chair is 45 centimeters long horizontally, 5, 10, 15, 20, 25, 30. That's not going to work. So I'm going to try 10, 20, 30, 40. That's going to work. So horizontally, I need to make sure I go, I guess, all the way to 50 here. And then vertically, the highest is 5, correct? The highest vertical is 5.05. So let's see, 1, 2, 3, 4, 5, no problem. That's going to work just fine. In this case, the y-intercept was actually stated in here, but it may not have been. So just watch out for it. So 0.5 is right there. 5, 1.36. 5 is right here. This is 1. And this is 1.5. 3, 6 is right about there. 10.04. So it's just above the x-axis. 20, 1.7. 1.5, 1.7. This is 7.5, so it's just under. 30, 4.68. This is 5, 4.5, 4.68 is right about there. 35, I'm at 5 here, so 35, I'm exactly back on 5. And then 40, 3.66. This is 3, 3.5, 3.66 is right about there. And then you just stop at, in this case, you have to stop at 45, right? We're told. I know that when we actually calculated it, it was what, 44.99. You would not lose marks because it's so close. It's impossible to get the 0.01 exactly, right? So you kind of just stop there. That's your scenario. And let's not forget about our equation here. That's the bad thing about a cubic. Is it 3 zeros or 2 zeros? 3 zeros. One more time, sorry guys. 0.06x squared minus 1 minus 1x plus 5, right? Oh, x cubed. X cubed, x squared, x 5. There we go. State the restrictions on the domain and range of this function. Could you do it? So basically the graph is the best way to do this, right? The scenario starts when it comes to the x values, it's 0 to 45 or 44.99, right? Trust me, the province would have made sure this turns out to be 45. They wouldn't, or they would have omitted that statement that said that armchair is 45 centimeters horizontally. They would have omitted that to not have contradiction. But we'll go with what we calculated. For the range, I do get to 0. I do touch. I found the x-intercepts. And I go as high as 5.05. There we go. If you like set notation, in this case, you can use x and y. I like the word, I added restrictions because sometimes they don't just go domain and range. They're like, what are the restrictions on the domain and range of this function? We need to restrict the function to just model the part we want because it continues technically on either side, top and bottom. Next, write an equation that will result in the arm being taller. I will adjust D, right? I will increase that. So I will go minus 0.008 plus 0.06x squared minus 1x plus taller, right? So we're going to go up. I don't know. Something that's bigger than 5. And that will conclude my lesson today. But I want you to at least get started on one more today. So I will just say that I'm gonna ask you to, because there's a bunch. Some have a lot of points. So I'm just gonna say 38 to 44. I don't expect you to do the entire thing, to be honest, because you have a life. But I need you to, hey, go figure. 38, and some of you work. I know that. I know that. I did the same thing. So how about we do a little bit of a compromise? I would say this is a good one. So I'm going to put a star on 38. I'm going to put a star on 42. 42 has a few nuances that you will encounter, given the fact that it's the number of years after 1979. So, for example, if they wanted like the gas price in 1980, we know that, right? It's this one right here. It's 1979, 1980, and so forth. So it has some nuances. Look at the key. And 44, I would say that shouldn't be too hard because the points are given. You need points to come up with a regression. So just focus on those dots, create a table, and come up with a cubic that would model the scenario. Okay, that's it for now. Just get started on the 38, and then we'll see each other on Monday. Pause there for